Okay, I think that's recording. Cool. All right. So I don't know. I guess you're all familiar with like Bitcoin, right? But maybe not Ethereum. Ethereum is kind of built on the foundations of Bitcoin, but then they added kind of a virtual machine to it, so it's like a decentralized global computer. So there is a white paper, should you want to read it. So if you do read it, please explain it to me if you do understand it, because it's pretty hard going. So yeah, so disclaimer, I'm not an expert at all. I've just been playing around with it for the last few weeks, so I'll show you a couple of things I know about it. But once you start getting into like Byzantine fault tolerance, then I'm afraid you're gonna have to go and read it yourself, because I don't know. But yeah, there's loads of information about it. So yeah, basically it's Bitcoin. So it works as a currency, a cryptocurrency, but also has got this virtual machine. So a bit like the Java virtual machine, there's a couple of languages that you can write in that compile down to this Ethereum bytecode. So we'll see a bit of the bytecode in a minute. You've got kind of three options at the moment. Well, sort of two options really. I guess you could write it in the bytecode. There's kind of an assembly that you could write directly. There's a step up from that. Then there's this low-level Lisp-like language, it's called. So this is an example of that. So you can see it is Lisp-like, but it is very low-level as well. As in, you've got to declare memory, stuff like that, right? So the benefit of that, I think, is you can obviously write tight kind of code, optimize it, and we'll see in a minute that every kind of operation you run costs money. So if it's a big contract, then I guess it makes sense to write it in this. So this is an example from something called ENS, which is the Ethereum version of DNS. So you get an Ethereum address, which is a big long string, and this maps those addresses to short English names, the same as DNS works. Then the next option is something called Serpent, which is based on Python. I guess I should be a bit more specific. So this is kind of a Python-y looking language, but I think at the moment there's some serious security issues with this. So the advice is not to use that. I think they're working on a new version of it called something other snake-like Viper. But yeah, that's like experimental alpha stage. So the kind of go-to language at the moment is one called Solidity, which is kind of JavaScript-y C-type syntax. So we'll look at doing a bit of Solidity smart contract development today. All right, so I'll just do like a quick Ethereum 101. So it's like a blockchain based thing. So one interesting thing you can do is go to this Ether nodes, and this is kind of a live view of the Ethereum network. So yeah, what I forgot to say is please just interrupt me with questions if you want to, if there's something you can think I could explain better or whatever. So we'll do a kind of interactive if you like. So this is the live Ethereum network. So you can see this is the number of full Ethereum nodes running globally at the moment, and the number is probably a lot higher because you can run it in kind of fast mode and it won't show up in this map. So this is the live network. So this is the full live network. So if you kind of equate that to a production system, then there's a test net. Well, there's a number of test nets, but this is the main test net. So this is a proper blockchain as well. So you can develop on this, but to get coins, you'd have to mine them or get them off someone else. So this still works exactly the same. It's just a test net, and then that kind of equates to a QA system maybe. And then there's a dev system, which is just kind of running a node locally. So you don't connect to any other peers, you just run one locally. And that's kind of the easiest way to do a bit of development. But so today I think we'll do a little bit of development on a local node, and then we'll try and deploy the contract onto the test net. We won't do mainnet today, but if you're interested, we can do that, and we could build I could do another show and tell. We build like a web front end to it, maybe, if anyone's interested. Okay, so yeah. No, it is to do with currency. So you can see the currency on it is called Ether. So you can see today that an Ether is worth what's the best one? So one Ether today is worth $332, and that's gone up. That's skyrocketed in the last year. So I think at the start of the year they were like $10 or something. So it would have been a pretty good investment, I guess. I just want to see. So yeah, so this is the chart of Ethereum for the year. So you can see there at the start of the year it was worth $12, and then it peaked at like about 400 sometime, and then it dipped down. This is when China banned some part of it, and then it's recovered since. But yeah, so that's it. So, but I mean, there's hundreds of cryptocurrencies now, right? So I think like Bitcoin is still the number one, right? And then there's Ethereum's number two, then Bitcoin Cash, Ripple, etc. Goes down and down. My personal favorite is Doggy Coins, but they're kind of lingering down at 36. So one Doggy Coin is worth 0.0019 of a cent. But still, for something that started as a joke, it's got like a market cap of $1 billion or something crazy. I don't know. Which one's market cap? Oh yeah, market cap. So Doggy Coin, the total value of all Doggy Coins in existence is $215 million. But yeah, that kind of pales into insignificance with Bitcoin and Ethereum and them. Okay, so that's kind of the cryptocurrency side of it, which is interesting, and you can create your own kind of cryptocurrency off Ethereum quite easily. There's this ICO, this initial coin offering thing. So we could create like a bluefin coin pretty easily based on Ethereum. But yeah, maybe getting off track here. So yeah, does that make sense so far? Yeah. So if you want to kind of send and receive Ethereum, you need an Ethereum address, which is kind of a big long string. So here's one, for example. So this is a view of, this is kind of a blockchain node explorer, right? So everything that happens on the blockchain is public. So if I sent coins to one of you guys, then the transaction would appear on here. I mean, it's anonymous because your name there's nothing to link you to a specific address. But if I could see all your history. So I can see that this guy sent some money there. So this is the list of transactions he sent, right? So he sent it to this guy. So it's all kind of out in the public. It's just that it's a kind of anonymous because there's nothing to tie the address to an individual. Yeah, so this guy's doing quite well for himself. He's got 4 million quid in the bank. Happy days. Right, so that kind of, you got any other questions about kind of the blockchain part of it, or the kind of fundamental how it works? Well, I guess it'd be better if I just kind of showed you how you interact with it and send coins, and then we'll look at a bit of the Solidity programming. So there's a number of kind of wallets you can get, but for any kind of development and stuff, you probably want this thing called geth, which is the kind of official Ethereum blockchain client, and you can run a full node with it written in Go. So you can install it and run that. So once you got that installed, so if I just wanted to connect to the main network, it would just be geth. So it just connects up, and then it will, I haven't done this, it'll start syncing with the blockchain, which will take forever. It'll take a couple of days, I think, at this stage. So as more and more transactions get written to the ledger, then the blockchain obviously gets bigger, and it takes longer and longer to sync. So I'll kill that. So I'll start it up in kind of developer mode, so we don't have to kind of sync with the blockchain. So I've just copied some commands down here. So this is geth again, just with some command line options to make it start up in developer mode. And then it will also start a JSON RPC server, and that's how we're going to interact with it. Can you read my screen there? Is it too small, or is it okay? Can you read the text? Cool. All right, so I'll fire up geth here. So that's now running an Ethereum node on my local PC, but it's not going to connect to any other nodes on the network. So anything I do here doesn't need to. I spilled my tea there. Doesn't need to be confirmed on the blockchain. So then I can start up a new instance and just attach to it, and this is going to drop us into like a JavaScript console. So then there's a number of commands. So if you wanted to create a new wallet address, right, you could say personal.new account, and then it's going to ask you for a passphrase. And anytime you want to send money or anything, you're going to have to put in this passphrase. And if you lose this passphrase, there's no coming back. You can't recover any funds or anything. They're gone for good. Right, so then this is my address here, right? And then I can list the accounts. So I've got 3 accounts here, and you can see it's just an array. So here's the first account. And I've done some mining here on this private thing already. So I should have some money in the first account, I think. So I can say, actually, I'll just put account 1 into this variable. Right. So now that's in there. I can say f.getBalance account 1. Right, and then I get a number. So there's one Ether coin, but then it's broken down into different denominations. So I think the smallest unit is a wei. I don't know how you pronounce that. So we can see how much is in that. So 1 Ether is basically equal to this many. What is it, a billion or something? Wei. So if I wanted to get my account balance in Ether, I can say from wei f.getBalance, and I've got 1,050 Ether in this account. What else can you do in here? Yeah, so that's kind of basic stuff. If I want to send a transaction, I can say f.send. So there's kind of GUI wallets to make all this easier, but if you're doing any development, it's handy just to be able to go in here and do stuff. So I just need to send it from account 1 to f.accounts. I'll send it to the new one I created. Value. And then this is in wei as well, so I can send it a load. Alright, so I need to unlock the account. Account 1, right. and then that account is unlocked for this geth session. So then that sends that transaction onto the blockchain. So if this was on the live blockchain, I could then take that address and go to Etherscan and see it wherever Etherscan is. I deleted it. Put it in there and it would find it. Oops. I mean, it won't find this one because it's not on this. That might match to something else. Okay, so that's how you would send and receive them. Any questions about that bit, or should we do a little bit of smart contract programming? I can go into like how the addresses and stuff are generated if you're interested in that. But should we do some smart contracts? Right. So any address that lives on the blockchain can either be one of two things, right? It can be either be a user or it can be a smart contract. So a smart contract is a bit of code that lives on the blockchain. You can send it Ethereum, you can send it Ether, or you can kind of execute functions on it. So I guess it'll make more sense if we look at building one. So there's a number of ways to get started to build them. I mean, there's plugins for like Visual Studio Code or Atom or whatever. But the easiest way is to use this online IDE called Remix. So yeah, you'll find it if you just Google Remix Ethereum. So this is it. It's a bit like kind of the web IDE thing, right? So let's write the simplest project, which I guess is Hello World, right? So this top line just says what version of the Solidity compiler I'm going to use, and then it's contract, and you give it a name. So Hello World, and you can see it's kind of JavaScripty. Similar to Java is a constructor, which is just the same name as the contract. I don't think we really need a constructor here, so let's just say function say hello, and it returns. So it's not strictly JavaScript, just that kind of C style syntax. Returns a string, hello, and then we'll just return hello world. Okay, so this compiles it live. So if I miss the semicolon there, it says there's an error compiling it. Put it back on, everything's okay. You can see what kind of Ethereum node you're connected to here. So at the moment it's just running one in the browser. If I wanted to connect it to the local one I'm running, you can do that, but let's just run it in the browser from now. So when you run it, this JavaScript VM, it's just for this browser session. It gives you a number of accounts that you can play around with, and this is the balance here. So this one's got loads of coins in it. So then you need to kind of create an instance. So that's going to compile it and deploy it onto the blockchain, which is done. So the gas thing is every kind of operation you perform on the blockchain, you've got to pay some gas, and the gas is Ether, basically. So how it works is the gas gets given to the miners. So every time when I deploy that onto the blockchain, there's people mining for Ethereum. So my action will get added to a block. That block will go onto the blockchain. Once the miners mine that, and it's the consensus on that block, our transaction will be deployed, and the miners will get their reward. So it's just said that, okay, I've created this contract. It's at this address, and here's the functions you can call on it. So now in geth, I could call that function. There's also this library web3, which you can embed into any kind of JavaScript application. So if you wanted to build a web front end onto it, you'd use that Web3 library. And then when I click say hello, so this is return the string hello world, and it's cost me this much gas money to run that operation. I mean, for something that doesn't change the state, you can add in the keyword constant, and then that doesn't cost any money, right? So that's not changing the state. So it's only kind of operations that change the state cost money. Oh, this costs money. Yeah. Yeah, that's exactly what you're doing. Really, it's like Amazon Web Services. You're paying for the computation that you're performing, and the storage as well. Yeah, that's the way of looking at it, really. So I can write something a bit more complicated if you're happy with that one. Does that make sense? Yeah. All right. So the idea I had was to write like say a lot of times people are writing them to what's a good example? Well, people can send funds and they get locked into the smart contract, and then when a certain condition is met, the funds can be sent somewhere else. So a good example would be something like what's that site? A crowdfunding site, right? So you could create a smart contract that said, you know, this is the target amount I want to raise, and people can send the amount in, and then the smart contract can say, okay, once I hit the target, then send the funds to whoever created the contract. If I don't hit the target by a certain time, then send the funds back to, you know, everyone who's contributed. So a simple version of that I thought we could write would be like a piggy bank. So say you wanted to save some money, so you want to lock some, you want to send some coins in, and once it hits a certain value, you'll be able to withdraw them, but not until then, right? So it's kind of like a piggy bank. So we can say create this contract. We'll have a target, unsigned integer, then target value, and let's make it. I'll close that one. So it's kind of confusing because it uses these ways for everything. So if we wanted to say the target is 1 ether, then the target's going to be that. Where's it gone? So basically we'll deploy this contract onto the blockchain, but we want anybody to be able to put money in. So we want to store kind of a map of addresses and balances. So there's a special type called address, which is an Ethereum address, and this is how you do a map, right? So we'll say, so this is going to create a map of users and their current balance. So I guess we want a deposit function, and that's going to so there's another keyword. If a function is able to accept Ethereum, then you give it this payable keyword. So now users can call this function payable and deposit Ethereum into it, right? So I could give it 1 and deposit. So then we'd want to update the balance. So can't type today. And there's another special variable, message, which comes into every function. A message is just some information about the caller, and so the message.sender is the person who's calling this. So we can say message.sender plus equals message.value. So that's going to update the map of addresses to balances with the value they've sent into this. So that should work. So let's write a little function to get the balance. So that will take in, I won't take in anything. That will. So this won't change the state. So we'll say it's constant, and it returns an unsigned integer, which is the balance. Get rid of that. So this will just return balances message.sender. So that should work, I guess. So let's try it out. It didn't work. Oop. All right, so it has actually created it. What was going on there? So this idea is a little confusing at the start, but kind of get used to it. So if we get balance, then our current balance is 0. Let's deposit some money into it. So let's put in 100, deposit it. And now if we get balance again, yeah, we've got this in it. So we've just deposited in 100 ether, but the balance is in way. So it's this big, huge number, right? So let's do the withdraw function, and then we're done. So withdraw. So what we need to do here is check if the user's current balance is 1 Ethereum or more, and if it is, then allow them to withdraw their funds. So it's going to return. It's not going to return anything, actually. It's just going to send the funds back, right? So if this is bigger or equal to the target, then we want to send them back. So we can say message.sender.send the balance, right? Okay, so otherwise we want to throw. So that will just okay, if we've been writing way too much ABAP, I'm forgetting my brackets. And that's obviously completely wrong. Right. Okay, so that should work. So that's all it takes really, is to write kind of a simple bank account or a savings account where you can lock up funds. Or you could also do it by date, right? But we'll just do it by target amount because it's easier for demo purposes. Right, so we've created our piggy bank. When we try and withdraw, it says exception because what throw does is throw it to an invalid opcode on the stack. So that's working fine. So let's deposit some money into it. Let's say we put in 2 ether, deposit, and yeah, I forgot to show you, but if you notice, the balance here will go up and down as we're depositing stuff in, and then when we do the withdrawal, it'll go back up. So now we should be able to withdraw, and it's worked. So that works. So in Solidity or in Remix, the other interesting stuff is in the details. So you can see it generates an ABI, which you can think of kind of as an API. So this is the list of, so if you're calling this from within a web page or web app, you want this, it's kind of gives you the API. So it'll list in the functions that you'll be able to call and stuff. And then there is this is the actual Ethereum virtual machine bytecode that's going to generate. So you could copy this, actually not that, this deploy stuff. This is what it's actually going to deploy onto the blockchain. There's some other interesting stuff. You can do like time travel debugging because it records the state as everything goes through. So how would I trigger that? You can see on where it throws here, right? I can go into the debugger and I can go backwards and forwards in time as it goes through. I can look at what's in all of the variables. So that's kind of interesting. Okay, conscious of time, so I guess let's try and deploy this onto a live blockchain maybe. So there's a number of ways of doing that. We could copy and paste the bytecode in here, start up a node on the Ethereum network, and then deploy it that way, but it's a bit kind of cumbersome. So there's a browser specifically for this called Mist, which you can use, but the easiest way I've found really is this browser. I have to show this. It's pretty cool if you lock it. It's got this fox that goes around. So this is a Chrome extension that injects that Web3 JavaScript library into the browser, and it's also kind of a wallet that allows you to manage your accounts and create accounts. So if I go in here, you can see the different networks I can connect to in here, right? So I can connect to this guy, if it was running properly. Okay. Yeah, so and then you can manage your accounts in here. So I've got that private account on the network and you can see the balance there. So I can use this then to send and receive and deploy onto that network. But we will connect to this Ropsten test network. So the interesting thing is this Ether scan has got a Ropsten version. So this is this blockchain explorer, but on the test network. That's my page. Right, so we're using this MetaMask and we're connected to the Ropsten. If I change my account to this Ropsten one, you can see I've got a balance of 4.7 Ethereum. So now I should be able to deploy onto this and execute it, call it. Okay, let's do it. So we'll connect to this injected Web3, which is what that Chrome plugin is doing. Refresh it. Yeah. Okay, so you can see it's connected to that. It's connected to the Ropsten test network through that MetaMask Chrome plugin, and it's found the account in there with that. So now when I click create, instead of creating it locally, it's going to actually deploy the contract onto the test blockchain. So this takes a little bit more time because it actually has to, there's real miners who have to confirm it. So I'll just up the gas price. So if you up the gas price, it gives more incentive to the miners to mine it. So if I give it 100, it should take hopefully a minute or less. Right, so that's off it goes. It's deployed onto the blockchain. It just needs the miners to validate that transaction. Okay, so just while that's doing that, I'll just show you quickly another way of doing it. So there's this thing called test RPC, which you can npm install, and that's a kind of in-memory blockchain as well. So that fires up and you can do all the same kind of stuff on it, and it gives you these accounts with some Ether. Another way of, if you're developing more complicated contracts, so you can have multiple contracts that interact together, you can import them into each other. You can use something called Truffle, which is like a framework for building these things. So you can npm install that as well. So I'll just show you what that builds. So if you do truffle init, it'll create a new project. So okay, so then you've got these following commands, right? So I'll just stop this one. I'll start test RPC again. So I'll just connect truffle to test RPC. Okay, so now we can just have a look at what's in here. So this is a good one, good examples. It's got a couple of smart contract examples. So this meta coin is an example of creating your own coin based off Ethereum, and it's also good because you can do test-driven development either in Solidity itself, so you can write the tests in Solidity, or you can write them in Mocha and Chai in normal JavaScript. So then you can do truffle test, and it will deploy those contracts onto this test RPC blockchain and then run the unit tests eventually. Okay, so it's the first time it's just compiling them. Let's switch back to the other thing while that does that. Okay, so this is now deployed onto the blockchain, right? So I can copy the address. I can go to my blockchain explorer, put in the address of the contract, and let's have a look at it. Okay, so you can see that it is a contract because it's got this contract code. You can see though, so this is my Ethereum address. I've deployed this contract, and this is the kind of bytecode for it. So now if I want to, oh yeah, okay, so you can see the unit tests have passed there, blah, blah. So let's send it one of these 4 coins, one, and then deposit. Let's give it 200 this time. So now that's going to take one of my ether and lock it up in this contract, or sorry, 2, I sent 2, and then lock it up in this contract. So it's the testnet is a little slow because people aren't kind of mining on it. There's not as much incentive obviously to mine on it because the coins aren't worth anything. But you can see this is transactions pending, and then when the miners mine that whatever block that's contained in, then I guess this balance should go up, and then I will be able to withdraw it as well. Yeah. Yeah, that's right. Yeah. So I can show you how to mine. Oops. So if I started up my testnet, right? So this is my testnet. Oh, sorry. But I want to drop directly into the JavaScript console. So I'll just put console on. Now I can say miner.start, and now I'm effectively mining, right? So now it's mining. You can see the little hammers every time it mines something. So it's super easy to mine on your own private net. And now if I check my balance, it will have gone up because I'll have got rewards for all those blocks I've mined. So a block is just like a group of transactions. So they could be the calls to contracts, or they could be people sending ether to each other. So a miner gets a block, tries to do proof of work, mine it. One particular miner will mine it, and he'll get that reward. Won't die now. Die. Oh yeah, exit. Right. Okay, so this hopefully should have gone through by now. Yeah. All right. So now the contract has got a balance of 1 because my user sent it to it. But say if Stuart sent a 10 ether to it, it would go up to 11. But then I'd only be able to withdraw my particular balance. So let's try. So hopefully you can see that the balance up here has gone down to 3.6 ether. So that's over the deposit limit. So I should be able to withdraw those funds. But each time it's costing me, a couple of pence. If it was on the live network, each one of these transactions would cost, maybe 10p or something like that. So I submit that. that should go through. It'll validate it in the contract code. It'll say, okay, his balance is bigger than the limit, so I'll give him back his money. Make sense? Sort of. Yeah. Okay. Right. Yeah. Yeah. Halting problem. This is why this is the whole reason that gas exists. So the gas limit. So once the gas limit's hit, the transaction will be cancelled. Yeah. So you're basically saying, oh, can you go on mute? Sorry, you're echoing me. Thanks. Yeah, you're basically saying for each step of computation, I'm willing to pay X amount, and I'm willing to pay it 300,000 times. So if the computation doesn't finish within, this number of steps, then cancel it. And if I was sending funds, the funds would come back to me, and everything goes back to the way it was. So yeah, so you can see that this has gone down to 0, and hopefully I will have got my money back. Yeah, so that's gone back up to 4. So that's kind of like a super simple smart contract. People do kind of crazy stuff with them. You can. Some of the ones I was looking at were like poker games and stuff like that. Gambling looks pretty interesting. But I guess there's a serious. They can do insurance and stuff like that, right? It's all public on the blockchain. I think that's all I had to show you, really. Oh, I'm way over time, actually, anyway. So, yeah, if you got any more questions, I'm happy to answer them. It's weird because you're kind of just executing this code on what is effectively like a global computer. So I mean, the other mind-blowing thing is this will live here forever. You cannot take a contract off the blockchain once it's on it. It's there for infinity, for as long as that blockchain exists. Yeah, I mean that's why they call it like Web. The library's Web 3, right? This is Web 3.0 rather than Web 2.0. But yeah, this Web 3 library. If you were to take a Fiori app, you could put this Web 3 library into it, connect it to a Ethereum node, and you'd be able to execute all this stuff. Yeah. Yeah. I mean, there's a lot of uses for it. I mean, you can like Wikipedia, or not Wikipedia. WikiLeaks are using it for like validating documents. So they would put like the MD5 hash of a document on the blockchain, and then that's if anyone wanted to check it, you can't tamper with it. Nobody, like a government, nobody can take it off the blockchain. It's there forever, and it can't be changed. But yeah, I saw there's quite a few sessions. If you look at that blog about the TechEd cloud platform sessions, there's quite a few on the blockchain that they're going to be releasing soon, I think, which is, it's not based on Ethereum, but it does have the same concept as smart contracts. I can't remember what it's called now. Yeah. It works on the same code that Bitcoin works on. It's just got this additional virtual machine bolted onto it. So Bitcoin is just a public ledger where you can just send coins back and forth. Ethereum is that, but it's also this virtual machine where you can build smart contracts. So you can build logic into it. pretty crazy, right? Yeah, but yeah, if you want to get started with it, this remix thing is pretty cool. You can be kind of up and running and playing around with it in no time. Yeah, all right, guys. Yeah, that's all I have. Hope you enjoyed that. I don't know if hope it made some sense. Yeah, I've only kind of scratched the surface of them myself. Yeah, I think it's kind of like a change in mindset. Like when you're trying to imagine what you can do with it, you just kind of think of all these kind of client server apps, but I don't know. It's probably like a new way of thinking. There's things that you could build on it that you can't imagine yet, or whatever. No problem. Pleasure. Hope you enjoyed it. Cheers, guys.